That's okay. We can see it. It's a big screen.
All right. That'll work. Oh, forgot to change my date there. All right. All right, guys. So are we recording?
Yep.
Cool. So it's September 6th. I'm just doing a brief report here to the Near Earth Imaging Lab. I was able to do some Pix4D processing this week, which was exciting for me. I have a family friend who decided to start an industrial hemp business in Reiner, Virginia. So I thought this might be a fun place to try out creating some ortho mosaics and using the Pix4D app with the DJI Mavic Pro 2. And so I used the app. I think it was, maybe an acre field, maybe 2. The Pix4D app took about 100 pictures, and of those 100 pictures, half of them came out super washed out. So I didn't include those in the processing. So if we may have gotten a more detailed mosaic. If I did include those, you guys probably know better than I do what the effect of a washed out photo will have on the end product.
Did you manually exclude those, or did you, hey, go ahead. Okay.
I did manually exclude them. I couldn't figure out how to transfer them directly from the Pix4D app to the program. So I ended up just pulling them off the SD card and looking through them, and they were, it was like the first half had, a lot of light problems. And so I just kind of didn't include those when I dragged in the other photos. So I'm not sure if you like to let Pix4D do that for you and decide which ones are best. I'm not sure.
If they were really washed out, then taking them out is probably fine. I don't usually worry too much about it. But more concerning is, why were they washed out?
Yeah, and that's sort of what I was thinking too. So I noticed when I was flying, pre-flying, it looked very washed out until I changed the setting from auto to, it just says A. I'm not sure what that stands for, but it seemed to do the trick. And I wasn't sure, because the 2 apps don't really talk,
right?
DJI and Pix4D. So we'll just have to see in future flights. I'll try it again. This was the first run, so maybe it was just sort of an anomaly.
Yeah, there's a setting on the controller. It has like 100 buttons, right? But like buttons will control 2 of the buttons will control the exposure.
Yeah.
So why don't you maybe Google that? I don't remember which ones they were. Top right.
Top right roller.
Yeah, it's the roller. So it's they say it's the roller.
Oh, the roller on the right side?
Yeah.
So is that like the opposite one that controls the gimbal?
Correct.
Same kind of thing. Okay. Oh man, well I'll have to check that out. I'm curious. So does that mean you're controlling it manually and it's not auto correcting, or it's just a setting?
It's the FSO. Okay. Yeah, it's just the FSO, and you change the setting as needed, but it stays the same for the entire flight. So if you want to keep tabs on that, if you know more about like camera stuff, then, because I don't know much about it, so I don't mess with it. But
I don't either, and I don't also try to avoid messing with it.
Yeah.
But I usually change, like, there's like I think it's the EV, but I don't know what is that.
Oh, like in the actual app itself of the.
Yeah, you can control it on the app, but there's like a button. You'll see it on the controller. It'll say like EV1, and you'll see it like there's like guidelines for, like, if it's a bright sunny day, then you want it at this, and if it's a cloudy day, you want it at that. And there's like control it with the controller and not an app. That's what I've been doing.
Got it. Okay, I'll keep messing with it. I'm sure one of those buttons will have to work eventually, right?
I'm sure there's a YouTube video.
Yeah, exactly. I was pretty happy with this ortho image here. Obviously, it's not very high resolution if you zoom in. Nothing like our ortho imagery collected at White Top. But maybe that's just because there were so few pictures. I think I flew this at 70% overlap. And the processing didn't seem to take long at all, maybe just because there were so few pictures.
Yeah, 50 will go pretty fast. If you start like bringing up the settings, right? So like full image processing and like high point density, your compute times are going to go way up, but your products are going to be better. But you can also, flying a closer mission with better, getting more images, like more overlap, is going to yield better results than cranking up the point density to high, which really takes a ton of time to process that out. So you should try it sometime to see how much longer, but it's a lot longer.
Okay. And do you suggest doing the double grid every time, or just if you're doing 3D models and things? Or?
Everything's a trade-off, right? It takes more time to fly, it takes more time to process, it does look better. Yeah.
Okay. And then you suggested to turn off the auto upload.
Yeah, I don't like it to do that because it takes too long.
Okay. If you're trying to do consecutive flights, that makes sense.
Yeah.
Yeah, I sort of found out that all the images are not only stored on the phone after it uploads, but also on the SD card. So I didn't know that was the case. So I was happy to figure that out.
Yep.
So I'm still working with my advisor to get the proposal together and in. It's been a little longer than I'd liked on that, but I've like to make some serious work, if not get it submitted next week. Let's see.
Before you move on, and maybe you guys know, one disadvantage to the double grid is that in Pix4D, I don't think you can fly a double grid that's not a square.
Oh, really?
I don't think so. Have you guys played around with that at all?
I haven't noticed that now.
I don't think you can.
One question.
Square or rectangle. So the double grid.
Or rectangle, right?
But with Ground Station Pro from DJI, you can do whatever shape you want for the double
That's
grid.
a double grid. Ground Station Pro.
Yep.
Is that their
Yeah, it's their
Modeling.
Max is 99 pictures though. And
99?
yeah, stupid. And also you aren't. It has. You can import KML. There's a lot of paywalls, unfortunately, or there's you have 5 free opportunities to do like ortho mapping, but other than that, it's like $30, $50.
Oh.
It really sucks, but for just generic kind of like waypoint missions, if you're trying to do that, it works fine.
Okay.
It's more to do.
It's ish. The only thing you have to be careful about though is if you make sure you have your start point above your takeoff area or really close by, because it goes straight to it, and you flip rocks like this. So it's really impressive.
Yeah, that's a good piece of advice. And one of the nice things about Pix4D is it seems to never do that. It
Yeah,
goes straight
it's
up
so
and then-
nice.
But that's actually how the Ellie Hessian's drone does.
Really?
It came in
Really?
from its last waypoint to its.
Oh.
So instead of going here and down, it went.
Wow. Okay, I was wondering about that, especially out here in Selu where there's so many trees.
Yeah, I've had that happen too. Sometimes, I don't do this on Pix4D, but I do this when I'm flying on the Busy Bee.
No,
I'll fly it up
Station Pro.
until I get out of range, and then I'll flip it to auto to start flying its mission. So then I manually make sure that it's clear of all of the trees before I ever flip the start
So
mission.
that was really my question. So there is a way to manually get it to altitude before pressing go on the Pix4D mission?
I think so.
Okay.
I haven't done it on the Mavic. I do that with the open source stuff, but
Okay.
I've never had a problem with it doing anything weird with the Pix4D capture app. It always goes before it starts.
So as long as I have a big open space with no trees directly above, it should go right up, and you can watch it and override if necessary, right?
Right. And you should practice the overrides.
Okay.
Make it start and then pretend something's gone wrong and you need to take manual control so that you're familiar with how to do that.
Sweet. Okay, we'll do. So yes, I'm working on updating my research timeline, setting goals and sticking to them. It's definitely a difficult thing for me sometimes on certain tasks that are overarching and large, but trying to be more realistic in my goal setting. I'm trying to capture and process as much imagery as I can in Pix4D in order to be prepared for a pre-leaf-off flight at White Top Mountain. And because the altitude there is so much higher, leaf-off is likely to happen much earlier, even probably sometime towards the end of September. So I'd like to get up there mid-month and do a flight just to just to gather some of that leaf on imagery. And then of course I'll go up afterwards and get leaf off imagery. So it'll be interesting to compare the two. Been working on logging all my drone flights, trying to keep track of my hours. You know, I guess the FAA recommends that so that if there were an accident, you can sort of justify your skill level and say, okay, no, I have, you know, plenty of hours of training and I'm a responsible pilot. It wasn't my fault, right? So, but that's been interesting, just kind of keeping track of like things you learn on each flight and keeping that in one log. So yeah, and then lots of other teaching related stuff going on I won't get into, but I think these are pretty realistic goals. That's all I have.
Okay, thanks, Riley.
Thank
Hey
you,
Riley,
guys.
when you go up to do the leap off, make sure that you probably don't want to go on a windy, like on a slight wind, but a really cold day, because the altitude sensors in the DJI drones are all barometric, and you can end up with like negative altitudes, unfortunately.
Oh, really?
Yeah,
When it's cold?
cold and windy. It's not like you can still fly, but it's still you get negative. Like out of Harper's area, they flew it was like negative 400 altitude.
The altitude that comes out of the DJI drones is always bad.
It's wonky, but
Yeah.
I mean,
So will that totally screw up like a landing or?
it didn't screw up a landing, but the processing. Like I tried to take those images and process them through ArcGIS, and I couldn't do it. And it also, I think, like it was hard to import that into ArcGIS from the extra outputs from Pix4D.
Yeah, and I would say that the altitude coming off of those Mavics is always be skeptical. Like Earl had problems with that. I've had problems with that. You've had problems with that. It seems to fly fine. That's the part I don't understand. Like you would think if it was off by 400 meters, it wouldn't work. But something separate between like the image tagging and the flight stuff, and I don't know why that would be, but that seems to be the case.
Does that screw up your process when the software is trying to piece everything together? Does it?
It's fixable.
Is it? Okay.
We can walk you through ways to fix it.
Okay. All right.
Basically, just have to set the altitude manually, and so that's what Earl did. He's like, I knew I took off at this height. I knew I flew at 100 meters. Therefore, I flew at this altitude. And
you just adjust.
But when you're processing in Pix4D, you can just, like when you're importing photos, you can just right click and you can just force it to be a certain altitude.
Okay.
That'll work.
Is there a way, like through the app or anything, to set your barometric, like your current sea level base pressure?
I don't know.
Before you take off. Like
I think
do that.
Put it in a plane.
I think it does that automatically. I mean, I was excited about that.
Yeah.
So yeah, I mean that's one of the weird things about the Mavic is the Mavics or the DJI. I guess I've only flown the Mavic too, but like it flies beautifully. But the geotagging on the images, just the altitude is wrong. Actually, it's not just the altitude, because I remember I did another one. I reported on this last year. I flew somewhere and it had me somewhere else by like 1.5 kilometers. It was super weird.
That was on campus, wasn't it?
I think it was the tree. I think it was
Okay.
middle school tree.
Strange.
And that turned out to be something in the firmware, or?
Yeah, the firmware updates seem to have solved that stuff, but
So it's not necessarily the altitude above ground level you're talking about. It's when it's making the above sea level Z value in the metadata.
sorry, say it again.
So it's not like, is it actually putting the AGL in the photo metadata, or is it actually trying to figure out how many feet above sea level it is?
Feet above sea level, or
Okay.
the
That's
data.
where the problem is occurring. Got it.
All right.
Thanks, guys.
Moving on next. Yeah, I'll go next. I only have a couple slides too. You want to keep your chair?
Sure. Your slides are
Gone.
gone.
In here. Anybody see what happened to that?
They're
Try to use
right
the
here.
Xbox controller.
Oh yeah, this might work.
No.
Is it here?
Um,
I guess it doesn't work.
yeah.
That's good. Is it on?
Yeah, it's not really doing anything.
Yeah.
You just do the slide, please. Next slide.
You can use the mouse. It's
Oh,
a
yeah,
wireless
I'll just use
mouse.
the mouse. That's fine.
Let me get the screen share started.
And it's Beth, right? No, oh no, there's another Beth. Colleen, right. Colleen. I've been like meeting a lot of new people lately. I'm sorry, Colleen. This is Colleen, everybody. Gonna tell us a little bit about yourself and we can all introduce ourselves.
I'm a first year grad student. I really like using geography for anthropology and archaeology. They can be used to like help each other out. So, I don't know what else to say.
Oh, that's good. Everybody knows me. Have you met everybody? Let's go around the table and just
I'm
introduce you.
Josh.
Hudson.
Oh, and say a little bit about what you do.
So I'm a second year grad student, and I'm finishing up this semester. I work with Bill Carsonson, and I'm interested in everything. Sorry.
That is true, yes.
Yeah, I distract easily.
I'm Hudson, second year as well. I work under Dr. Fingal, and I do on cloud reconstruction classifications.
Jim, you know me, working with also, I guess we'll decide on the lab topics today. Leaning towards geomorph and landslides classification.
I'm Sam, yeah, Dr. Fingal student, first year. Yeah, you'll hear about my wide variety of interests, but I have the geo in it.
It's pitch day today, so these guys are all going to pitch five thesis ideas.
I'm Jack. I'm another one of Dr. Fingal's new students, and I like the coastal stuff and a lot of the technical and the drones and playing with all the gadgets and stuff.
All right, so we'll go ahead and get started. I've got a short list today. A couple of quick, interesting articles kind of came across my email this week. This is an R package called MoveCost that does least cost path modeling, which actually has a ton of applications to archaeology. I think one of the articles I sent you was related to that. Who's all in Yang's R class? Okay. So if you're looking for something to do for a project or whatever, these cost paths have really a lot of interesting applications. So it'd be time well spent probably if you've got something more important to do, or if you got something that works for your thesis, then you should do that. But if you're just looking for a topic, then
I wonder if Molly might benefit from
Yeah.
oh yeah, that's true.
Mm-hmm. Oh, the road.
the road
Yeah.
network, mining.
Yeah. I'll send her an email to remind her and send her some on Slack. This was an interesting paper. So one of my former colleagues is Wei Lo at Northern Illinois University. He actually does a ton of stuff on geomorphology. So he does remote sensing, geomorphology, a little bit of geographic education. Really well known and does really awesome work. So if you have a chance to Google Wei Lo, I know you're giving your pitches today, but we're still searching for another couple weeks. His stuff would be, I think, a good target for you to kind of just look through and see if anything looks interesting. This paper is really cool. This was done by his PhD student. So one of his interests is Mars, and what they're trying to do is basically, we've already gone through some stages of reconstructing stream networks based on the DEMs. And so what the PhD student is doing is trying to figure out if the angle of the junction angle, so if this is kind of your bit of a stream here, kind of going that way, if that junction angle is a certain size, then it indicates that the climate at that time was warm or cool, because the amount of water flowing in will kind of dictate roughly what angle that is. So it's a really interesting study. It's kind of like fairly comprehensive, I think. Really interesting stuff. So that is of interest to anybody. It's kind of neat work. So there's all this it's a lot of moving pieces to kind of make that all happen because a lot of it has to be automated. It's a lot of data to look through, so everything has to be automatic. It's really cool.
What journal is that?
This one is
Is it the
Earth and Planetary Science. Something. Letters, yeah.
Okay, I wasn't sure if that was.
They had another one in. Right. Okay. This was kind of a little side thing. I got a new phone, so I needed a new phone holder. This is a little 2-piece phone holder that I had printed. This is just a little like receiver piece that bolts onto the controller, and then this can basically just be sized to fit your phone, and this little piece goes into this little spot. So, and then this is the telemetry unit, and it just tucks in there. So it's nice to make the adaptation. But the only substantive kind of research thing that I did this week was to go gather some data on the Franklin County tornado. So this is a larger project that we're kind of partnering with the National Weather Service, trying to see, how we can use drone imagery to better quantify, categorize, describe tornadoes that have gone through. So it's more than just kind of flying them. We want to use the imagery and process it in 4D, create point clouds, create orthophotos, use some sensing techniques. What information can we wring out of these sort of really high resolution and 3D data sets? So this tornado was here. I just added, this is Blacksburg, there's Roanoke for reference, and so this was just a little bit south of Rocky Mount. And this is the path that the tornado took. So Rocky Mount is right here. It was just south of that. And I went and sampled this area right here, which is a park. So this is the part of the park that I went through. This is imagery that I took when it went through, or the day after it went through. So you can see it knocked down a lot of trees. The whole path kind of runs back, kind of continues off to the bottom left, and it extends out to the upper right. You can see that it knocked down this pole. So I mostly flew kind of this grassy area over here. So there's one of the baseball diamonds. So I basically flew this whole section. I also did I didn't put a note in here, but I took some 3D video that basically flew this path and then another, 1,000 meters down this way. But it ended up too dark, and I don't know what happened. The exposure, it was a very cloudy day, but it didn't work out. So I've got 2-3 video captures that are kind of useless. I'll have to fly that again, but the pictures turned out okay. So I flew the Mavic. I did 3 flights. There's 2 north-south flights, one at 90% overlap, one at 80% overlap. And then I was going to do an 80, this should be an 80% overlap. No, that's right, a 90% overlap here. But this is, the thing behaves weirdly sometimes. So I think, Riley, I told you occasionally you'll fly a mission and the pictures didn't save for some reason.
Yeah.
In case the drone flew at about 1/3 of its programmed speed and took a pile of images this way. So I was trying to fly just a normal mission, and I got this super slow, high resolution thing. And so I think it took what's that?
Did you end up stopping it? Is that why it's only about?
I did, yeah, because it was just taking a ton of time. And the tornado path actually goes through here. So I had imaged most of that. And so this is just kind of nothing too important. I was going to use that as like contrast, but yeah, it was taking forever, and I didn't think it was going to be able to complete the whole thing anyway.
How much different does it look with the tornado having gone through?
Pretty different. So that's
Okay.
that's the reconstruction. So you can see the path kind of cutting through right here.
Yeah.
And then basically we've got sort of untouched-ish forest right here, and then we can do a comparison. So we'll kind of know what comes out this way compared to what's going on in here. So you can do sort of basic things like count how many trees came down, which would be sort of the simple thing to do. But I think that there's more interesting things we can do with like entropy or some autocorrelation metrics or some other things that will hopefully yield some interesting results here.
How long after the Or tornado was that?
Oops, can you go back 2 slides? The one that this one?
Yeah, the flight itself was.
So I had flown this flight, Noel.
I remember you went down.
Yeah, so I went down the day after. I took a lot of video that ended up not being, so that was when I brought the Mavic like heads up display. So I was kind of having a lot of fun with that, and I didn't fly. I actually didn't know where it went, right? So that's one of the downsides is the day after a tornado, you don't have, like, they were actively out surveying where the path went. So I'm kind of going into this blind-ish, like, I talked to the National Weather Service damage assessors. They're like, it went through here, and they kind of gave me a couple of waypoints, but you kind of don't really know what to fly that day, which is a bit of a, so one of the things for this project is figuring out, like, when should you fly? And I don't think you should fly the day after. I think you should fly.
Can you?
The reports come in.
Could you use like Sentinel data or something to actually see where the track is gone? I mean.
Yeah, but probably not soon enough.
Okay.
And I mess with like like using Landsat to like pick up on tornado damage, and it's like these resolutions not great.
Yeah.
Like if it's a gigantic like EF5 tornado, you can actually do some pretty interesting analysis because you see like the gigantic scar. But something that's small that like maybe like knocks these trees down, it's gonna be probably hard to notice.
That's just a couple pixels, right?
Yeah.
This was an EF3?
Two.
Okay.
Yeah. And in fact, I think it was an EF1 for a lot of its track. I think it was only
Yeah.
EF2 for.
And that's the problem with like the damage scales, like it's all kind of if like it passes through a cornfield, it doesn't hit anything, or it's an EF0, or now they're calling it like undetermined.
Yeah.
But,
So that I think is the benefit of the project. Is
Yeah,
there
yeah.
is there a signature in tree data that can help you more accurately
oh yeah.
figure out what it really was?
What's wrong with it.
So I think that'll be interesting. This is the 3D Pix4D reconstruction. I think it turned out pretty well. So I'd saved all of the data in the Virginia Tech UAS folder, which you should now have access to.
Yeah.
I think you and I are the only ones with access to it. I must have created it at some point. So
Yeah.
but you've got access to all of the data that's been flown, so if you want to start looking at it. So that's it for me.
So that's-
Yep.
Oh, cool. I just had a question. I have to cut out soon, but I remember in the mapping with drones workshop I took, they talked about forests being a little bit more difficult to map, and there were certain settings to change to compensate for that.
Yeah. So you want to fly a really dense pattern if you can, because it doesn't do a great job with the tree reconstruction.
Uh-huh.
So you want to fly a forest like at 90% overlap.
Really? Okay.
So that's one of the reasons that I wanted to fly a 90 and an 80. Below 80, I knew it probably wasn't going to be any good, but I wanted to have a comparison of like what does 90 look like, what does 80 look like, to make sure that the signal that you're getting out of those is reliable. So like if you fly it at 90 and you come up with a method of processing it and say, this works, would you get a different result if you flew it at 80 and the reconstruction isn't as good? Is the method of reconstruction going to affect the indicators? Hopefully not, right? But it'd be good to know that for sure. So my big goal is to really focus on the REU stuff. I'm going to be leaving town with any luck today, so I've really got to focus on this article. My goal for next week is to complete the literature review, which is already about half done. So hopefully not more than a couple of days to work on that to finish that off. And then to sketch in the methods and results. So that's just sort of breaking down how I want to tell that story. And then I'll worry about sharpening it up later. That's it for me.
Sweet.
Hudson, you got a presentation?
Yeah, I've got some fun.
All right, we'll do that, and then we'll go to you guys because you guys are all doing the same thing.
Okay, I'm cutting out, but I'll check out you guys' pitches. I want to see this stuff. So,
Great, you ready?
talk to you guys later.
And Colleen, you're just here to hang out, right? Today?
Yes, there's one.
Okay.
But yeah, can I talk to you afterwards as well?
Yes.
Okay. Sweet. So, as far as getting the LiDAR viewer on the HTC Vive, I've been browsing like forums that Oliver Krilos, who's the producer of LiDAR viewer, has kind of like typed in on a little bit. Particularly Reddit. You can find anything on Reddit. But yeah, so the HMD, the controllers and the head mounted display are recognized by the program, but it's the lighthouses, these little tiny things that are having trouble tracking the user. So you have to have the program call the trackers to be initiated, and then they have to be fed through the VR, OpenVR platform through Steam. And there's some sort of disconnect between those. So I'm thinking, my hope is it's just like path related and how things are kind of organized hierarchically in the folders. But I'm hoping I probably give it like a fresh restart and then go through all this stuff, because there's things you have to do to manually path your own folders or things to it in order for it to work. But yeah, that's kind of like the output you're supposed to be getting, where it will tell you, all right, like this is how much charge you have left on your folders, and you're good to go and start utilizing the programming stuff. But without proper tracking techniques, it's kind of limited as far as to person capabilities. Yeah, so I keep getting a weird host or a weird OpenVR host like has been dropped instance when I start to run the Vive tracker. So hopefully, yeah, with a fresh restart or fresh installation, it should kind of work itself out. If not, it's a bigger problem, but we should be okay with that. And then something I've kind of looked at is another kind of VR software, and I was reached out to by one of their salespeople after I downloaded it, just to kind of see like what it's doing. It's primarily focused on research based in VR, I guess from their taglines or whatever. But the exciting thing about Vizard or Bizard or whatever you want to call it, I don't know but is that it's leverages the power of Python, whereas other game engines are primarily built on C++. So Python is more accessible. It's more kind of user friendly in regards to a lot of data analytics in geography sphere. But yeah, looking through kind of like the library and community toolkits that they have, there's a bunch of interconnections with LiDAR toolkits, as well as I think LibGlass is in there, which is kind of an open source library for dealing with point cloud data. But yeah, with that being the case, I was able to instantiate a VR scene and have it recognize the system, the HTC Vive, and was able to put it on and immediately see a scene that wasn't like, there wasn't anything put in it, but yeah, I was kind of seeing how if you were to initiate libraries and then have those libraries become buttons within the scene itself. So it's like you wanted to scrub the point cloud for removing ground, that could be a button within the VR sphere, and it automatically run that script from the package and then deal with the point cloud in real time. I haven't kind of messed with the rendering capabilities of this as compared to other game engines like Unity or Unreal. So I'll have to kind of continue that little search, but it was kind of interesting to see how quick that was.
So when I was at UC Santa Barbara, the giant the Alisphere, which is their immersive
Cave or whatever.
Yeah, it's like a cave. It's huge. It's like a 12-meter globe. And you're inside, and there's this bridge that goes across. But the guys that were working on that were also working on this. So this is really, I've been wondering what happened to this project, and I didn't have a reason to get back to it. I thought that it probably had died off.
I found it somehow. So.
But it seems like not. And so if it's still going strong, this is a really good avenue, because
Yeah.
those guys are really good. They were just getting started when I was there, and so that was like 10 years ago. So this is really promising. I'm glad you found
I
this.
don't know how I stumbled upon it. I think I was looking for like images or something, and then it popped up. But yeah, it's leverages Python, which is kind of really good for it's like,
For sure, because then we can get a lot of our algorithms and we write in Python in there, and they can be buttons, and that could be sweet.
yeah. So
Cool.
I just don't know how it deals with rendering and shaders and stuff like that compared to like a big engine like Unity or
Yeah, usually these things take a bit of a hit in that
Right.
department, but if they add the lighter processing bits, then that's
Yeah.
good too. You don't want to have to.
So yeah, I'm hoping that in addition to this, I think it might be on the next slide, but with a web server like XAMPP, which is kind of feeding that data into the engine, that it will kind of take off some of that processing power on the engine itself, so that it can just focus on rendering rather than actually real time loading data in and whenever it's manipulated or changed. So yeah, this is scheduled again. And then kind of the goals was going to get for next week, get the proposal done, dusted, and signed off. Because it needs to get done, and as well as rectifying that lighthouse issue with the 5 and the Linux system. Kind of poking around, digging in there more, seeing if it's more user error or something within their system or file hierarchy. And then, yeah, like I was talking about, kind of exploration of XAMPP and how that can kind of be integrated with the game engine. So,
And Blizzard is definitely worth
Yeah.
the investment. Let me know if there ends up looking like there's going to be costs involved, because I'm pretty sure that they are trying to make this a.
it's free right now.
Okay.
I don't know if there's paywalls.
Yeah,
later
keep
down the
me
road or
posted
something
on that,
like
but that's definitely a great avenue. The proposal stuff, send it to me as soon as you get it. Really try to make an appointment with Todd Ogle as soon as you can.
Right.
He said he wanted to make it in today.
Yeah.
He says, by the way, that you might drop by. So this is the guy that does virtual reality and LiDAR stuff.
I'll shoot him an email today. So.
He may pop in.
Yeah. So then, I don't know if I talked about previously, but Poetry is kind of the pseudo feeder from XAMPP. So it displays the point cloud data as well as adds additional features for point cloud sizing and all that kind of stuff. So I've been browsing forums, Reddit, about how people have kind of attempted to implement that web server hosted point cloud through Poetry into game engines, just so it can be kind of less restrictive and more based on manipulation rather than processing as a whole. Cool deal. That's it. So.
And Josh, you're just here to hang out today, right? All right. Pitch time. Who's up first?
I'll go
Excited.
terrible. There it is.
So I think what we'll do is we'll hear all 5 pitches and then we'll give feedback. So plan on hearing all 5 and then we'll give feedback about those 5. And everybody should type in a little bit with some comments.
So, slide report for today, cool background that I found from Microsoft. What was it need? So went over an article before my pitches or whatever, and read an article on detecting translational landsat scars using segmentation of Landsat data and DEM data in conjunction with each other in British Columbia. It was in the Canadian Journal of Remote Sensing, so it's still pretty good even though it's not American. But in relation to my main thesis idea of through segmentation algorithms for remote sensing and landslides. So the study area was in the southern part of British Columbia in the Chilliwack Basin, and they used a combination of 1 to 20,000 aerial photographs and Landsat ETM plus data for image classification within eCognition. I'm not sure what that is, and you look up that, but their algorithm was based on separating out unvegetated from vegetated from NDVI values, and as well as steepness of slopes, and also the it was whether or not, like, if it was I guess kind of like a roughness factor sort of was kind of in there. I didn't really understand that part. but the results they were pretty good, 74% accuracy by omission and 77.5 from omission, which is kind of so. And there was 287 identified in the area for the thing, and they took 40 for random comparison. Of those 40, they took 10 to ground truth and actually walk. So in figure area, like A up here is the A area of the figure. This is just an area, regular aerial image photography that they classified either by hand, and then so they did that for a base comparison, kind of what they saw, and then raw data from the Landsat, segmented it, and then here's the vegetated, unvegetated separation, flat land versus steep land. So it was, the gradient was below 15 degrees versus above. In this case, yellow is above. The other one is the green is below. Or no, I don't know what green is in this sense, but purple is flat land right here, up here. So, and then after the supervised classification, the red is your landslides, orange is your talus. Right down here, this grayish area is rock outcrop, but you also have some clearing and snow kind of in this range right here. And so for the errors in commission were attributed to logging roads, which is one right here, I believe, right there. Which they didn't, but they didn't include a road level or road class in their classification, because when they did, it caused other issues, such as they had less accuracy by commission or less accuracy by commission when they had that in there. So it was interesting to see how they had to deal with the bare ground versus logging roads, because both of those kind of played an issue into, because they steep unvegetated areas. They also had a height to width ratio that from 0.5 to 1.5 for their calculations as well in the classification. So, then my 5 thesis topics.
Sorry.
There you go.
Did they take into account for any like soil differentiation, or was it just based off of the DEM and the?
It was mainly based off of the DEM and the Landsat data, but they did classify out the talus, which is the stuff coming off of the landslide, as well as bare ground. But I think they didn't do. I don't think they did much with it. With just like based on the. They mainly did. They didn't do dirt. They didn't do dirt slides. This is like rock, mainly rock chunks.
All right, so upper middle column at the top. That's like manual supervised or
I
manual
believe so.
classification,
I believe so.
and then
I
the
read it.
2 below that is the output of the program.
Yep.
So, what's your impression of the accuracies there? Like, qualitatively speaking, how good of a job is it doing?
I think it's doing a pretty good job. I mean, this matches up pretty well with this, and this is a single aerial, or composite of a few aerial photographs. So, I think that.
What parts are good and what parts are not good? Let's focus on that.
All right, what parts? I think
Show me what matched and show me what didn't match.
the long streaks right here matched up pretty well. I think there's more. I think some of this talus probably could have been reclassified as just a rock outcrop, like right here, see where it says right there. But at the same time, the Landsat images, because there's 6 bands of the Landsat, they were able to look through the trees and identify, because right in this top one, the manual classification, a lot of this area that has a landslide, which is probably a road maybe, or something like that. Like this right here, that's all vegetated in their aerial imagery. So I think the Landsat imagery and the auto classification definitely did, I think, overall better than manual classification.
Wait, what?
What?
Say that again?
I think the Landsat supervised classification did better than the manual, because it picked up on some of these, like right here. I mean, these are kind of there, but they're a whole lot bigger in the supervised classification output. So
I would have guessed that the manual was like pretty much correct. It's not true.
I would say no, because of the vegetation. That's a really big problem right now, at least with VDOT. So VDOT's having the trouble. How this plays into other, let's say, I guess, a real world problem is VDOT is trying to get trying to find somebody or find a way to map roads and redo the road center lines because landslides and creep have shifted the roads down so many, by so much. And you can either go and ground truth that, or you can look at aerial photographs and you might miss roads that aren't really exactly on maps anymore or just aren't visible in aerial photographs. And so I think the landside data.
But people always do a better, pretty much always do a better job.
Like, why would you put that much time and effort into making a manual one to find out that it's just
Did they try unsupervised classification? See what the computer hashes out?
No, they didn't. But I mean, they went out and ground truth. I guess what is that? 10 of 287. Some low percentage point of it. But I mean, they took a quarter of the random test areas, and they ground truth. So,
Can you put the PDF for the paper in the?
Yeah.
So there's the Neil Google Drive space. Go like if there's extras, so if there's like little bits of stuff, something whether it's an article or whether it's a little piece of code you wrote, feel free to just dump those in the extras folder, and that way if somebody else wants to look at them, they can get a hold of them. So yeah, I'd be interested in looking at that one.
and that's just the way that I interpreted it, was that the supervised classification did better than the aerial photograph interpretation. So my 5 thesis topics, one, which is what I'm really focusing on, putting all my eggs in that basket, is using existing algorithms / techniques of Landsat ID on a single reference data set and compare them to each other for accuracy. And this would help me with my future learning goals of learning about algorithms and machine learning, so I can design my own algorithm, and hopefully that will be better than the other existing algorithms that are out there. Second idea is use picnophylactic interpolation to generate more accurate DEMs from LiDAR data to identify geomorphological features that are of note, cave openings, something like that. If you have that high resolution LiDAR data. Then the third one, make interactive geomorphologic map, different scales through 3D printing and image recognition to create an interactive learning tool for use in museums and in classrooms. Also use multispectral aerial satellite imagery classification to ID exposed rocks.
Can you go into 3 in a little bit more detail?
Okay.
Tell me what you mean by that.
Which part of it?
All of it.
Okay. So the geomorphologic map, use it to identify areas that are limestone and karst controlled. So rolling hills, hummocky, that kind of stuff, to identify potential, to show students what to expect when you're in like a karst where there's possible caves and that kind of stuff, but also could be useful in industry to identify areas where you might have a problem with subsidence and sinkholes and stuff like that. And using image recognition, like actual video, like active video recognition, by having a camera above a 3D printed map. And like you said, like you had talked about, using a laser pointer or something like that to identify an area and bring up a interactive or a database entry that talks about what's in that area. And then so use multispectral or aerial satellite imagery classification to ID exposed rocks and potentially different types of rocks. Could be useful for mineral identification, as well as a teaching tool if you wanted to go with that route. I know they've done it with more subsurface and stuff on Mars. Maybe some parts of the Earth would be kind of cool. But I think it'd be neat to see if you could do it in this area through trees and stuff like that. That's not in vegetated areas. and then use near infrared imagery classification to ID exposed rocks and debris from geomorphological phenomena. So, let's say, a landslide, for instance, or caves open up or something like that, and you can look at stuff that's inside of it or around it, and potentially use near infrared, especially if it's more focused on vegetation health, to identify where the plants are stressed. So maybe there's a cave, or maybe there's a landslide, or some other type of interesting geomorphologic feature that could be of use to somebody. So.
Right.
I guess no comments yet. So.
That's time for comments. Okay, or we'll go back one.
Yeah.
All right, Hudson, you want to start out? Yeah, I want to. So general comments are totally fine. If you can pick a favorite and a least favorite.
Okay. Yeah, I mean, I think one that you're probably most interested in is probably number one.
Yeah.
In regards to algorithms and being able to compare them and have a comparative baseline reference data set to compare them, and then potentially create your own, be the case. Yeah, I think as far as like the identification of geomorphological phenomena, I think, yeah, it's kind of hard for me to picture exactly what instance or case it would be. Like, so I mean, yeah, there are topics.
That one was kind of like an offshoot, it's like, well, what about doing something like this? But, it's an idea
Right.
getting thrown out. So.
Gosh, feedback?
So I was still trying to figure out which one. I actually really like the idea of identifying the geomorphological phenomenon.
Yeah.
I think that's pretty neat. I like some of the other methods. It is. I mean, I guess I hadn't thought of near infrared, but I guess that makes sense. Maybe neat. So I thought that one was pretty good. We're supposed to say favorite and least favorite. Don't quite. So I'll be honest. I'm googling
Pick up black.
number 2. I'm actually googling it right now because I don't quite understand. I don't quite see it. So that doesn't necessarily mean anything. I just don't know it.
Okay.
With number 5, if you're looking specifically for vegetation, you may also want to consider using red and near infrared.
Okay.
Because those are the two bands that are used when classifying, or those are the two that are used for vegetation indices.
Okay.
You may want to consider including red as well. For that, you seem really interested in the first one. I mean, I'm not much of I haven't worked much with algorithms and all that much, so I can't comment much on that, but you seem really interested in it, so it'd probably be a good route.
I definitely like the first 3 better than the last 2 because the last 2 contain rocks. You care about rocks? That's okay. You care about rocks. Okay.
That makes sense.
The first one is solid. That one's probably the most that's a thesis on Rails. You can map that out and you will accomplish a thing and you will have a publishable article at the end. Right. And that's a big asset. So that's probably my favorite. I think 2 and 3 are they're higher risk. I don't know if they're higher reward or not. It's hard to say. The nice thing about 1 is if you wrote an article about that, that's going to get cited. People are going to care about that. It is going to if you want to go on for a PhD, you can definitely springboard onto the next thing. Okay. The second one, I think seeing pigment lactic interpolation is one of Walter Tobler's ideas, and the idea is that you can take a relatively coarse data set, especially something gathered in like polygons, and then refine it. So like building better population models. Like you know what the population of this county is and that county, but can you smooth that out in a way that sort of makes sense? And so one of the interesting applications of this is actually the DEM data. One of the advantages of it is that it's more supportive of discontinuous data sets. So a lot of smoothing or interpolation will over smooth. And so if you've got like Chicago or Washington, DC or some urban area, like it wants to make that into, if you imagine population as a vertical, wants to make that like a hill, whereas what it really should be is more like some sharp, like a pillar, right? Like some of those differences are sharper than they would seem. And so picnoflagic interpolation preserves those in an interesting way. I think I have not seen anybody, and I think this is a really interesting topic to compare. Like if you take SRTM data and apply picnoflagic interpolation and use LiDAR as like ground truth, like how good is it? I don't think anybody knows. I think that would be interesting. And the third one I think we've talked about, I think that's like the diciest one. So that's something, you know, Hudson's project is a little bit like this, right? He knows what he wants to do. He knows kind of how he wants to get there, but there's a lot of uncertainty in how that's going to happen, right? So I think it will work, but there'll be a lot more trial and error and probably user testing. So one of the ways in which you can assess how well a thing like that is working is you can put it in front of people and have them use it, and they can give you feedback, and you can measure things about what they know. That's a very time-intensive process. So a lot of my PhD data was of that kind. It's a ton of work. So you've got the work involved in building the thing, and you've got the work involved in making it work. I think it's very interesting. It's one of the topics I'm most interested in. But probably that one's the most work, I would say. That's
IRB and all that kind of
yeah,
stuff.
IRB for sure. Yeah.
It's the worst.
I do want to get the lab oriented that way. Like that is important to me. And so I don't like if you're interested in that and you want to take that on, like I would support it. But it's
So
rough.
is there, so the research that you've done like currently, like is there algorithms or machine learning processes to potentially identify like potential landslide areas in like say everyday satellite imagery?
There's some. I mean, I found a few but a lot of it's focusing on landside susceptibility and stuff like that. And so mainly looking at the larger picture. And so this would be good for going back and creating a landslide database, because then you could turn around and then use that also for landslide susceptibility. Because if you have a landslide at the base of the slope, there's more than likely going to be like stress fractures and stuff like that up like farther up the slope in the surface that you can either see through a scarp or tension cracks and stuff like that. So
Is it like, I don't know, not ethical, but like if you were to take imagery before a known like landslide location, like several known landslides, and then say like, all right, could this have been predicted based off of this algorithm? Like how much is caught by that algorithm to determine whether or not this could have been predicted or
Is there or
yeah, I don't know if that was like
so
research.
so yeah, I think it's possible, especially along the coasts where they do a lot more LiDAR surveys a lot more often. So when major storms hit, oftentimes there's money to go see what happened. And so I know that on like the coast of California, like that's not only are they sort of likely to have a landslide, like they happen all the time, but then it's pretty easy to map too because there's not a lot of forest cover, like scrub, and so it's pretty easy to see where one went. What's that?
You have LiDAR in coastal areas too.
Yeah, that's the point. Is there's a ton of data. Inland, I think it's harder because you might only have one, and then you're looking for just remnants of what happened, and then you can sort of post hoc try to say, well, like with this predictor. I actually don't think that the predictors of landslides are that great. Other than sort of the standard toolkit of like slope and, you know, all of the main metrics, like, I think that's about as good as it gets. I don't think you can be like, next year,
Yeah.
Yeah, you definitely
Like,
couldn't like
you don't know any
pin it
weather
down
conditions
time-wise,
anyway.
but
I just didn't know how like academics was drawn to that post hoc like idea of definitive or
you can definitely do it. But yeah.
If I could throw out, like casually throwing it out, so as far as predictors go from like a soil standpoint, and I guess your geology,
yeah.
From a soil standpoint, like there's soil scientists that are pretty confident about, but they're also going out and they're taking samples, they're looking at it, they're doing all the slope measurements. And so if you could overlap it, like, I mean, they're pretty confident that it works. Like they'll go out and say, this failed, and an engineer will say, no, we did this, and the soil scientist might say 20 years, and that slope collapses.
Yeah.
And so there's stuff there, but I don't know.
So, but I guess I would, you know, that to me sounds like they've got a donut, like, the soil scientists have that problem buttoned up. Like, I don't know that there's much that we can bring to the table that they probably haven't already done.
right.
You know, I think we'd be coming in without all of that good information, you know?
You'd be trying to turn it into remote sense somehow, but they could be working on it. But all the ones I know
Yeah.
are older. Like, it's an older generation, so I don't know what's current. They might already be doing it.
So like I know a few companies right now are out there, like so GSI, Geostabilization International, they just came to Radford and they've been training like both their first responders essentially, they're surveyors where they can present the job to the company as well as their engineers themselves on how to fly a landslide and fly an area to look for scarps and stuff like that. Like, what are some further problems? And so this would be able to be put in the hands of either, the government or like, let's say VDOT, the government entities, ODOT, all those kind of guys so they can survey their state, let's say county by county, if there's landslide, ladder data sufficient. So they can create a more comprehensive map of current, landslides that have happened recently, older ones that have happened in the past 100 years or so. If that's capable, I mean that remains to be seen. But that's like that's kind of like where I'm envisioning it going. And that's like I'm playing the long game with that first topic because I want to get my PhD, and something I want to do is to do that kind of remote sensing and identification of hazards and stuff like that. So,
PJ?
I really think the third one's pretty interesting. It's not like a kind of a pain to do all the IRB protocol stuff like that. It's, that's just the way it is.
Yeah.
But I do think it's really interesting, especially if you do something in VR with that. Maybe you could like peel back like one layer of something. And
Penn State did something like that where it was like a virtual field trip. It was like sedimentary, like rock. They were like going through in VR and like identify like time frame wise.
Where'd you run across that?
That was went to a conference and they've been on it at their the main guys there, but yeah, it should be Penn State like virtual field trip or something like that.
yeah, it's pretty interesting. You could even do something where like it almost like takes you back in time. So it's like a limestone formation. You see like if it was a shallow sea or something like that.
you can do a whole kind of geologic history.
Yeah.
Field trip in that respect.
And I think the last two seem kind of difficult, especially I would imagine identifying rock types would be pretty difficult without like actually being able to kind of look closely at them. Like
Kind of strange, but I mean it'd be interesting to see based on magnetic data from satellites and other surveys like that, as well as reflectance. You kind of need to see like. Because I know you can do it kind of like in non-vegetated areas, like on Mars. I think they've done it like and also in Antarctica, they look underneath the ice.
Yeah,
But it'd be cool to see if you could do it in vegetated areas and how active.
yeah.
Like Mount Rogers is nearby is a volcanic rift zone where
Mhm.
where stuff was separating out.
Something interesting I saw in one of my undergrad classes was we were looking at photos after a typhoon hit Japan of an area, and there's a shift in the predominant rock type from granite to granodiorite, and you could really see the difference in landslides after all the typhoon and the rain and everything in the two different rock areas. So that might be something
Yeah,
kind of indirectly,
yeah.
different types of rock.
Yeah, definitely. I think the first and second one are my favorites. Particularly the second one, I think it's kind of cool how like the smoothing feature is a pretty big problem. I think it applies to a lot of disciplines. I think that you can kind of carve out a pretty cool corner in the geology sphere and with geography, obviously being this hard, but like kind of branch that to like one of those domains or allied disciplines, the geology, right? I also kind of like the near infrared identification, but then it kind of runs into the problem like you might need to do like true data, would be heavy. Or you could build like a machine learning algorithm to kind of identify them.
I
It'd be
mean,
cool.
I feel like with any of these though, you still need to go out.
Yeah, you
You
still
still have
need
to
to
go out and ground truth, which is definitely not an issue. I mean, I'm down to go climb some hills if anyone
Yeah.
wants to go on a hike.
But then that kind of like narrows your
Yeah.
look, I guess.
Yeah.
Spotlight.
You ever been to the Devil's Marble Yard before?
I haven't.
That is a crazy formation. Like, it's wild.
Where is it?
It's like 2 hours north of here, up towards the what is it, the Natural Bridge, yeah.
Okay.
It's like a mile and a half worth of huge boulders that are
That's
like
cool.
formed from
Marble?
Yeah.
There's tons of old landslides on your way there.
Oh yeah.
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 Good point.
Near it. We'll go up.
You're good. Who's up next?
You're saying.
Mark.
I'll go. So,
Thanks for the feedback. Appreciate it.
Oh, thanks for the presentation.
so my thesis topics, my pitches. The first one is my favorite one, is monitoring coastal erosion with UAV photogrammetry. I like beaches a lot, sandy beaches and barrier islands, which is basically the whole southeast U.S. coast from Maryland down to northern Florida. So they're very dynamic and quickly changing environments just because sand is just constantly moving around. There's nothing really solid holding them together. So the waves, the tides, and wind just kind of shape them constantly. So I'd probably do this over a seasonal time scale because winter is usually when the weather tends to be rougher. But obviously hurricanes are kind of like really big events that can really shape a beach. Like this bottom photo is some dune scarping near Myrtle Beach over Hurricane Matthew, which is a relatively small hurricane, but it's still cut away. A lot of the dune, the Fort Dune Ridge, probably come out about like here or so to the edge of it, but just cut straight through it. Another thing, this is a photograph from somewhere in Virginia. It's an overwash fan where the dune ridge was basically breached by the waves and storm surge, and a bunch of sand went out into the marsh behind it. So obviously this is pretty weather dependent, but if you could get something like right after like before and after a big storm, would be great. That's kind of rolling the dice a little bit, but chances are you can probably find some place that had some erosion or even big tides before Hurricane Dorian.